Chapter 2, Hyperbolic and Inverse Hyperbolic Function. So this is the hyperbolic and inverse hyperbolic function definition. Actually, definition of hyperbolic function much similar to trigonometric function, but the difference is we just add the letter of h in the name of hyperbolic function, and the hyperbolic function are not periodic like trigo, and is also used to apply in some building structure in the shape of curve, such as hanging cables. So the basic definition of hyperbolic function is in the terms of exponential function is like this. Okay, so basically hyperbolic function, we come from two basic, which is one sine hyperbolic x, which is equal to e to the power of x minus e to the power of negative x over 2, and the second one is cos hyperbolic x. Then we will get e to the power of x plus e to the power of negative x over 2. So from these two, we will come out with tangent, cosecant, secant, and cotangent. And hyperbolic function also have their own identity like trigo, which is the first one is cosecant hyperbolic x plus sine hyperbolic x is equal to e to the power of x, and the second one is cosecant hyperbolic x minus sine hyperbolic x equal to negative e to the power of x. So this is the table between hyperbolic identities and trigonometry. So the tables is the comparison between both. Okay, so you can see this table to answer the question later. Okay, so let me do for the first step first. Okay, sorry, I erase first. Okay, so the first step, we want to solve for the question. We want to prove these identities of hyperbolic function. So at our right hand side and our left hand side must be same. Okay, so we have our left hand side is equal to secant h square x plus tangent h square x must be equal to our right hand side, which is 1. So let me do for our left hand side parts, which is secant h square x plus with tangent h square x is equal to 1. Okay, so when we solve this function, we substitute the value of secant hyperbolic square x that we have seen in our table previously, which is equal to 2 over e to the power of x plus e to the power of negative x, and we close the table, must be put square outside because we have square here. Okay, then for tangent hyperbolic x is equal to e to the power of x minus e to the power of negative x over e to the power of x plus e to the power of negative x square. Okay, so for this example, we need to expand first. So let me expand one by one. So 2 over, we expand for the denominator to see what is the answer first. So e to the power of x plus e to the power of negative x square. So when we expand this bracket, we will get e to the power of x plus e to the power of negative x is equal to the first one, e power of x multiply e power of x plus with e power of x multiply with e power of negative x for the second one. And then the third one is plus e to the power of x multiply with e to the power of negative x, then multiply plus with e to the power of negative x times e to the power of negative x. Then we solve for this one, we will get the answer is equal to e power of 2x plus, okay, this one means x minus x. So x minus x, we will get 0. So e to the power of 0 is equal to 1. So plus 1 plus e power of negative 2x. Okay, so we solve for this one, we will get e power of 2x plus 2 plus e to the power of negative 2x. Okay, so this is for the first denominator parts. Okay, so this is solved for denominator. So let me solve for our numerator. Okay, so our numerator is e to the power of x minus e to the power of negative x times e to the power of x minus e to the power of negative x. So we expand one by one. So the first part is we will get e to the power of 2x minus e power of x times e power of negative x minus with e to the power of x times dengan e power of negative x plus e power of negative 2x. So we solve this, we will get e power of 2x minus 2 e power of negative x plus with e power of negative 2x. Okay, so we solve until here, then we substitute into our function. Okay, so with the first part, we will get 2 square. So 2 square is equal to 4. So 4 over, okay, the first part answer, which is this one, e power of 2x plus 2 plus e power of negative 2x plus, okay, denominator, this is the answer for our numerator, e power of 2x minus e minus 2, sorry, minus 2 because we already cancel here, x minus x, which is 2 here. So 2 plus with e to the power of negative 2x over, same from our previous example, which is e to the power of 2x plus 2 plus e power of negative 2x. So we can simplify, put it together because we have the same denominator here. Okay, so we put it together in one side. We will get at the bottom e power of 2x plus 2 plus e power of negative 2x. And then at the top, we have 4 minus 2. So 4 minus 2 is equal to 2. Okay, so 2 plus e power of 2x plus e power of negative 2x. So if we look at here, both numerator and denominator are same. Then we can cancel this. We put it as equal to 1. Okay, so it shows us our right hand side is equal to our left hand side. So the answer is proof. Okay, let me look at example 2. We also want to prove these following identities. So let me put our left hand side. Okay, it should be left hand side is equal to right hand side. Okay, but let me do first. So we choose our left hand side because it's better or easy to us to solve for the longest to the lowest. So cotangent hyperbolic square x is equal to minus 1, sorry, is equal to e power of x plus e power of negative x over e power of x minus e power of negative x. So this one minus 1. So when we open, okay, this one is square because we have square at our function here. So we have square here, sorry. We have a square. So this one also we need to square lah. Okay, so we expand this bracket. At the top, we will get e to the power of 2x minus or plus 2 because here we have plus symbol. And then plus with e to the power of negative 2x over. At the bottom, we saw we will get e power of 2x minus 2 plus with e to the power of 2x minus 1. Okay, because the bottom and the top have two different values here, which is positive 2 at the top and negative 2 at the bottom. So number 1 here, we need to multiply by the denominator itself. So we just write down back the value at top, which is the numerator, e power of 2x plus 2 plus e power of negative 2x over e power of 2x minus 2 plus e power of 2x. Okay, then this one we need to minus all together. E power of 2x minus 2 plus with e to the power of 2x. Okay, so we can cancel what? We can cancel e power of 2x, e power of 2x, and then e power of 2x. This one is e power of negative 2x. E power of negative 2x. So when we simplify, we will get 4 over e power of 2x minus 2 plus with e power of 2x. So it's equal to 2 over e power of x. We factorize the number at the bottom, which is e power of x minus e power of negative x. And it is equal to cosecant hyperbolic. Okay, let me draw below, which is equal to our right hand side, which is cosecant hyperbolic x square. Okay, so this is our second example. Okay, let me move to the next example, which is number 2. Solve the following hyperbolic equation. Okay, so we want to solve for this one. So let me cancel this and put it as 7. So first we need to change cosecant in terms of sine by using identity first. So 4 multiplied with 1 plus sine hyperbolic x plus with sine hyperbolic x minus 7 is equal to 0. So when we open, we get 4 plus sine hyperbolic x plus with sine hyperbolic x minus 7 is equal to 0. So this is, we have square also. Square. Okay. So we rearrange first. We put hyperbolic trigon that have square in front, followed by sine hyperbolic x. Negative 7 plus 4 is equal to negative 3. Okay, then we factorize this function. Okay, so when we factorize, we will get 4 sine hyperbolic x minus 3 multiplied with sine hyperbolic x plus 1. Okay, so we take one by one. That we use this part first. So we will get 4 sine hyperbolic minus 3 is equal to 0. Okay, but sorry, don't forget to write down the angle first. Okay, so sine hyperbolic x is equal to 3 over 4. So x is equal to, we just press our calculator. We move sine inverse to the right hand side. We will get our inverse of hyperbolic, and just press your calculator. You will get 0.6931. Okay, so for the second part, okay, this is the first part, and then this is the second part. So for the second part, we just write down back what we have in the bracket. Sine hyperbolic x plus 1 is equal to 0. So sine x is equal to sine inverse hyperbolic negative 1. So we calculate, we will get our x is equal to 0. So let we look at our next table. Okay, number 2C, 2 bola. Okay, solve the following hyperbolic equation. So this question want we to solve this example. Okay, number 2 bola. Okay, so let we substitute this one, change to tangent. Okay, this is the first equation. This one is the second equation. So we change second hyperbolic to tangent hyperbolic, which is 1 minus tangent hyperbolic 2x square. plus with 9 tangent hyperbolic square 2x is equal to 3. Okay, so we simplify this one. So 1 minus tangent hyperbolic 2x square plus with 9 tangent hyperbolic square 2x is minus with s equal to 2. 2 we bring to the right hand side. Okay, so now we have two same tangent and also tangent, and then at this one we have 1 as a constant, and at the back we have 9 as a constant. So we can put it together since it's like we have the same. Okay, so we solve, we will get our, sorry, this one is tangent. Okay, so we get 8 tangent hyperbolic square x square 2x is equal to 2 minus 1 or 2 plus 1. So 2, 3. So this one is 3. So 3 minus 1 is equal to 2. So we only want the value of 2x here. So 2x is equal to 2 over 8 tangent inverse, tangent hyperbolic inverse. Okay, then we solve, we will get 2x is equal to tangent hyperbolic inverse square root of, this one is 1 over 4. Okay, so square root of 1 over 4. So that we will get our x is equal to 0.0746. And then for the second one, we have 2x is equal to tangent hyperbolic inverse negative square root of 1 over 4. And then we solve this one, we will get our x is equal to negative 0.2746. Okay, so for the second one, next we have C. We want to find this example, so let we simplify this by substituting sine hyperbolic in terms of cosecant. So we have sine is equal to cosecant hyperbolic square 3x minus 1 minus 5 cosecant hyperbolic 3x plus 5 is equal to 0. So we open this bracket and we simplify this, we will get 2 cos hyperbolic square 3 minus 5 cos hyperbolic 3x plus with 7 minus with 2. So we get 5 here. Okay, so we factorize this. Let we put a as cos hyperbolic square 3x. Okay, so it will become 2a square minus 5a plus 5 is equal to 7. Okay, so when we factorize this function, we will get 2a minus 3 multiply with a minus 1. And then we will get a is equal to 3 over 2, which is a is equal to cosecant hyperbolic square 3x equal to 3 over 2. So 3 over x, we move cosecant square to the sorry, we didn't have square here. we just have cosecant here. Okay, then we move to the right hand side. We will get cos hyperbolic 3/2, and then we solve for this. We will get our x is equal to 0.3032, 0.3208. Okay, then the other one is a minus 1 is equal to 0. So let a, we will get a equal to 1, which is our a is equal to cosecant hyperbolic 3x is equal to 1. Okay, so from here we solve and get our x. We will get our x is equal to 0. Okay, then let we look at our next subtopic. Okay, this exercise you can do by your own. Okay, so differentiation and integration of hyperbolic function. So this is the table of hyperbolic and trigonometric function table. So the first example, we want to find dy dx for the following equation. Okay, so we differentiate our left hand side. First we will get dy over dx, and when we differentiate cosecant hyperbolic, we will get, okay, because this is power of negative 3x, so we differentiate, we will get negative cosecant hyperbolic multiplied by e power of 3x, okay, multiply with cotangent e to the power of 3x. Okay, then we get, so from here we will get negative, okay, multiply with 3x, e to the power of 3x. This is comes from our differentiation of product e to the power of 3x. Okay, so from here we can solve. We will get 3 e power of 3x times with cosecant hyperbolic e to the power of 3x multiply with cotangent hyperbolic e power of 3x. So this is the answer for example A. Okay, next let we move to the example C. Cancel with your example B because it's wrong. And then we solve for C. We want to solve for dy dx. So differentiate this one. We will get u over v because this is a quotient rule. So let me solve for the quotient rule first. So the first one, you will get your u is equal to tangent hyperbolic 3x, then du over dx, or we have u prime. Okay, u prime is equal to secant hyperbolic square 3x multiply with the differentiation of 3x is equal to 3. Okay, then we minus. Okay, this one for u prime. Then we have v equal to 2x, so v prime is equal to 2. And another one, we just replace, okay, because of is equal, so to y dy dx. Okay, so we substitute into the formula of v u prime minus u v prime over v square. Okay, for this is for quotient rule, so we will get v u prime, so v u prime 3 secant hyperbolic square 3x minus with uvx tangent hyperbolic 2x. Okay, So from here, we need to divide by v square. So our v is 2x, so 2x square. Okay, this one also is equal to dy over dx. But we have two values here. So we solve by move number 2 here to the right. And then we open the bracket. Okay, so our dy over dx becomes 2x multiplied with, we just expand, no need to write down back what we have done. Okay, we have 2x, 2 equal to 3, then we have 2 times 3, 6. So 6x second hyperbolic square 3x. Okay, minus with 2 tangent hyperbolic 2x over with, okay, because we have 2 here, so 2 be moved to the right. So 2 square equal to 4 multiplied with 2. We get 8 here. So over 8. Okay, don't forget to write down 8 square because we have 8 square also. Okay, this is example D. Okay, next. So this is example C. Next, we move to example D. So for example D, we have equation of 2x cos hyperbolic 3x. So we want to find dy over dx. Okay, this also a product rule. So our u is equal to 2x. U prime is equal to 2. Okay, then this is u. So v is equal to cos second hyperbolic 3x. Okay, then we find for v prime. So v prime is equal to sine hyperbolic 3x multiplied with 3. Okay, so we find our dy dx by using the formula. So dy over dx is equal to, okay, remember the product rule is u v prime plus with v u prime. Then we get dy dx is equal to 2x multiplied with 3 multiplied is sine 3x plus with cos second hyperbolic 3x multiplied by 2. Multiplied by 2. Plus multiplied by 2 here because we differentiate 2x, we get 2. This one u v prime plus with v u prime. Okay, so we expand this one, 2 times 3 at the back, we will get 6x here. So 6x sine hyperbolic of 3x plus with 2 cos second hyperbolic 3x. So this is our answer for the example 1. Okay, next, let we move to the number E. Example 1 also, but number E now. So for this case, let we differentiate one by one. Differentiate dy square, we will get 2y dy over dx. So this one is u, this one is v. So u over v. So differentiate sine inverse. Okay, so our u is equal to sine inverse e to the power of 2x. So u prime is equal to 1 over square root of 1 minus e power of 2x square. Okay, so our v is equal to tangent hyperbolic x square. Okay, v prime is equal to second hyperbolic square x square times dengan 2x. Okay, so 2y dy dx is equal to v u prime minus uv prime over v square plus v3. Then we just substitute the value that we have found previously. So our v is equal to, sorry, this is your u prime. Okay, so our v is equal to, okay, this is our v actually. Actually, v is equal to tangent. Okay, sorry, this is tangent. Okay, so v is equal to tangent hyperbolic x square. So v is tangent hyperbolic x square multiply with u prime. So u prime is 1 over square root of 1 minus e power of 4x. Okay, I expand this one already. Okay, multiply with 2x, 2e to the power of 2x. Okay, this one, sorry, multiply with 2e to the power of 2x. Okay, then we need to minus with our uv prime. So u is sine inverse e to the power of 2x sine inverse. Okay, multiply with uv prime. So our v prime is second hyperbolic square x square multiply with 2x. Okay, then we simplify this one. We rearrange this function. So you just try by your own, rearrange all together, then you will get the answer is equal to dy dx is equal to 2 exponential power of 2x tangent hyperbolic x square over 1 minus e to the power of 4x minus 2x sine power of negative 1 e power of 2x second hyperbolic square x square plus with 3 over 2y. Okay, so all here need to divide by 2y multiply with tangent hyperbolic x square kan dia. Okay, so this is the final answer for this question. Okay, let me look at our question F. Okay, so question F, we change this question exponential, we change with ln to x. Okay, it's have a mistake. Okay, when we differentiate cosecant, we will get sine hash, okay, with 2x sine 2xy, the angle must be like downward, and we differentiate the product inside, we will get 2x dy over dx plus with 2y. Then at the right hand side, sorry, this not okay, so differentiate 3x square, we will get 6x plus with 1 over 2x multiply with 2. This one multiply by 2. Okay, so we simplify this one. We open the bracket. To x sine hyperbolic 2xy dy over dx plus with 2y sine hyperbolic 2xy is equal to 6x plus 1 over x. Okay, so we simplify this one. We just only want to take dy dx at our left hand side. So left we will have 6x plus 1 over x minus with 2y sine hyperbolic 2xy over 2x sine hyperbolic 2xy. Okay, so this is the answer for question F. Okay, let me do number example 2a. Evaluate the following integral. So the first one we have sine hyperbolic 4x dx. So let u is equal to 4x. Then we need to find du over dx, which is we will get 4 here. Okay, then dx we move upwards and 4 move downwards. So dx is equal to du over 4. Okay, so when we substitute sine hyperbolic 4x dx is equal to sine hyperbolic u. So we have substitute u with 4x. Okay, multiply with du over 4. Okay, then we solve again. We move up the constant in front. We will only integrate sine hyperbolic u du. And then we will get 1 over 4 cosecant hyperbolic u plus with c. Okay, this is the formula from previous slide. Then at the end is equal to, don't forget to substitute back the value of c here. So 1 over 4 cosecant 4x plus c here. Okay, so this is example A. Okay, next we move to example B. So let u, okay, we have u equal to 5x because this is a product function. Then our v is equal to cosecant hash 10x square. Okay, so we need to find our du over dx first. We will get 5 here. And we solve for dv over dx is equal to what? Okay, no need to find. No need to find v here. We just replace with u only. Okay, so for this one is equal to, okay, cosecant hyperbolic u square. U square multiply with du equal to dx is equal to du over dx equal to du over 5. Okay, we change the position. So du over 5. Then x. Sorry, this is a mistake. There are some mistakes here. So let we substitute our u with the angle inside of the cos. So this is our u, let u equal to 10x square. Okay, then we will get our du over dx is equal to 20x. So dx is equal to du over 20x. Okay, so then we solve for this function, which is integrate Okay, integrate for 5s cos u dx is du over 20x. So then we can simplify this. X simplify, so we get 1 over 5 here. Sorry, 1 over 4 here. Because 20 times 4 is 5 times 4 is equal to 20. So 4 is here. So then we simplify this function. 1 over 4 cosecant hyperbolic u du. So the answer for integrate cosecant, we will get sine hyperbolic u plus with c. Okay, then we substitute back the value of u from our previous slide, which is our u is equal to 10x squared plus with c. So this is the answer for question B, example 2. Okay, next we move to the example C here. So for example C, let we choose our u is equal to x squared. Our u is equal to x cubed plus 4. It's same like our previous example. Okay, so our du over dx is equal to 3x squared. Okay, so from here we will get x squared multiply with cos u multiply with dx. Okay, dx move. Dx is equal to du over 3x squared. Okay, multiply with du over 3x squared. So then we will get here 1 over 3 we can put in front, x over 2 and x over 2 at numerator and denominator we can cancel this. So we will get cos hyperbolic u du. So we just integrate for cos. Okay, integrate cos, we will get sine hyperbolic. Don't forget to substitute back our x. So our x is x cubed plus 4 plus with c. So this is the answer for example 2c. Okay, next we look at the example of D. So we have cotangent. Sorry, this is wrong. We just change the equation with cotangent hash square 2x cosecant square 2x dx. Okay, so let we choose either one. So for this case, I want to choose cotangent as my u. So let u equal to cotangent hypotenuse 2x, and we will get our du over dx is equal to negative 2 cosecant hyperbolic square 2x. Okay, so we change the position. We will get dx is equal to du over negative 2 cosecant s square 2x. Okay, so from here we just substitute back our function. Okay, so from here we just substitute, we will get is equal to integrate of u square. Ada s, we just write down back. Okay, multiply with du over negative 2 cosecant hyperbolic square 2x. Okay, then we can cancel this because it's same. Okay, so what left is equal to 1 over 2 negative here. We just put negative in front. So equal to negative 1 over 2 multiply with u square du. Okay, so negative 1 over 2 u goes to 3, u power of 3 over 3 plus c. Then we just replace back the value of c here. So we get cotangent hyperbolic cube 2c over 6 plus c. Okay, next Let we look at our example. E. Okay, so for example E, we have sine hyperbolic 4x cosecant x dx. Okay, so what we need to do is let our u is equal to sine. So let u is equal to sine hyperbolic x. Okay, so du over dx is equal to cosecant hyperbolic x. Then we change the position, dx move to upwards and du move to the du, which is cos x. Okay, so from this one we just replace sine with u, so we get u power of 4 multiply with cos x dx. Okay, so dx we just replace dx with du here because we already find our du. Dx in terms of du, we will get here du over cos x. Sorry. Okay, so we can cancel this because it's same. Then what left is u power of 4 du. Okay, so later on we substitute back the function. Then we will get u power of 5 over 5 plus c. Then u power of 5, we substitute back the value of u that we have let previously, which is sine hypotenuse power of 5 s over 5 plus with c. Okay, so this is the final answer for 2E. Okay, next we do for number f. Okay, so for f, we have square root of tangent x multiplied with secant square x dx. So let our u is equal to tangent hyperbolic x. Okay, so our du over dx is equal to secant hyperbolic square x. So from here, we just substitute square root of u secant hyperbolic square x multiply with du over secant square hyperbolic secant square x. Okay, so from here we can cancel secant square. So what left is square root of u du only. Okay, so square root of u du means u power of 1 over 2. So when we integrate, we will get 3 over 2 u power of 3 over 2. Sorry, 3 over 2, we need to change the position. We need to change the position 2 over 3. Okay, then don't forget to write down back our u, which is our u is tangent hyperbolic x to the power of 2 over 3 plus with c. Okay, so this is the example for hyperbolic inverse function. So hopefully you all will know and understand. Then you can do the exercise 2.